Hi everyone, nice to see you here. So I hope so far you have fun, you got some insights, you grab a tasty lunch, and now you're sitting in your comfort zone and want to learn a little bit more about generative AI and Amazon EKS. Amazon EKS and generative AI fundamentally change how customers and companies engage to each other. There's a lot of different open source tools which can help you advance your generative AI journey on top of the Amazon EKS. There's also quite, I would say, cool projects which you can use for your own journey, like Jupyter Hub, Ray.io, Argo workflows on top of your EKS cluster. In today's session, we also dive deep in customer stories, how our customers are solving their own challenges in machine learning world on top of the Amazon EKS. My name is Max. Today with me my colleague Alex. Let's get started. Before we jump into the world of generative AI, Kubernetes, all of these great things, I think it's worth to discuss first why Kubernetes become like a go-to platform for machine learning applications. And to address it, we can try to start with challenges, basically, as always. So it always starts with choosing your framework. So you want to build some machine learning application. You choose your framework, you choose libraries, you write some code, you maybe bring some drivers in order to have access to your GPUs, in order to accelerate maybe your training or inference. And at some point you need to move forward, right? You need to move it from your local workstation to maybe to another environment. It might be challenging. Then when you figure it out, you move forward, you choose how you are going to use your resources. So basically you need a lot of resources in order to support your distributed training or inference at scale. So with AWS you can get everything with a click of the button, right? You can get your compute resources, you can get your storage, networking resources, everything is available to you. But there is still one thing which might be complicated for you, because you have to figure out how you're going to manage it and orchestrate according to your machine learning applications. And it's not always easy. You also need to figure out after that how you're going to build your observability, because you need to see what's going on in your platform. You need to understand how your algorithms and model behaves. You need to see your logs, your monitoring, metrics, and so on. And it's quite challenging to decide which technology you want to use. There are a lot of maybe discussions in your company, and it's quite difficult, I would say. After that, there is also a very important part, which we shouldn't forget, is security and compliance, right? And whenever you get all of these expensive resources to your organizations, these compute resources or GPU resources, so you need to figure out how you can share it across your company in an efficient way and organize your identity access management at scale and make sure it still don't stop your company to evolve and move faster. As a result, by handling all of these questions related to the infrastructure, you basically take your time from delivering the business value with your machine learning workloads. And obviously, that's where we start thinking about the things. So how we can solve it. And most likely a lot of people will come up with the idea that let's use Kubernetes. And it's a great idea. So a lot of our customers use Kubernetes in order to start their machine learning journey and dive into the generative AI world. When you choose Kubernetes, you basically make an inherent decision that you are going to use containers. And containers is a great thing, because it helps you to solve the first challenge, basically. It helps you to solve the challenge of dependency management. You can pack everything inside of your container. It will be your source code, it will be your libraries, maybe some additional tools for machine learning, it will be your drivers. Pack it and move efficiently across different environments. In this case, you'll get flexibility, portability. Also, you are going to use your resource efficiently. When we move to Kubernetes, so there are a lot of built-in capabilities which can help you to move forward. So when you're trying to address challenges related to the distributed training or your inference and scale. Kubernetes has built-in capabilities which can help you to solve it. You can use horizontal pod autoscalers in order to meet demand for your users and customers from the inference perspective, or scale your infrastructure in order to support your distributed training and expose your models to the more data. After that, Kubernetes also give you great possibility to use the resource efficiently. You don't need to spin up additional virtual machines in order to run your applications. You basically deploy your container, you specify the resource quotas which you need to use for this particular container, and then it runs under the cover and helps you to scale it towards your needs and control it. There is also an important thing from the technical side, like organization standardization. So basically, when you choose Kubernetes, you also get some built-in mechanisms which helps you to separate the context between different teams. So in this case, you can manage proper access to your different workloads. You can share some resources to particular teams, and you still will be able to see how it works under the cover. You can monitor it, so you stay secure and compliant, and it all brings you important value. It can be achieved with different mechanisms inside of Kubernetes, and one of the popular is basically namespaces. So you basically set up a namespace for a particular team, and they work in their isolated environment. And one thing which is I really admire is basically this open source community. So when you choose Kubernetes for your operational platform and running your applications, you also have possibility to adapt and grab a lot of the innovation which is moving and evolving in the scope of the open source community. So, and very important to mention that a lot of the foundational models which right now, I mean, in particular right now, driving this generative AI revolution, were actually built on top of the Kubernetes because it was flexible and useful for them, and they, I mean, teams who works on it understand the value. From the logical perspective, so when your machine learning engineers or data science teams, they're trying to start their journey, so they're pretty straightforward workflow how they can adapt Kubernetes for their needs. So basically they finish some stuff, I would say magic, on their local machines, right? They do some maybe configuration, they define the resources which they need for their particular model or algorithm, and they're ready to deploy it to your Kubernetes cluster. Then Kubernetes basically picks it up, and with controllers it allows to meet the requirements which you need. So basically it can expose your model to a lot of the data, it can scale your distributed training pods in this case, and also it can meet demand from the inference perspective. So if your users may be accessing your platform applications from time to time, you can scale towards your needs, basically scale out and scale in based on demand. So as a result, you get very efficient resource utilization, and in case of failure, so Kubernetes helps you to recover fastly and safely. And of course, it's not the only reason why customers choose to use Kubernetes for their in-house platforms and development. There is very important value that from strategic perspective, Kubernetes gives you an ability to run your applications in different environments. So let's imagine there is a company, they have some different applications and stacks in-house, and they want to, for example, distribute it or run it in AWS, they want to run it on edge, they want to run it on premises for some reasons, maybe for regulations. And Kubernetes allows them to do that. It brings them abstraction on top of the infrastructure primitives. It allows them to build their own platforms. So basically, you choose the proper tools which you're going to use for your cluster, and then with your decision, your other teams in the company will use the same. So basically, you share the standard across your company, and result, you'll save a lot of the time and efforts. So basically, it brings us three key advantages. So the first one is basically you will save your time. You're going to reuse what you already have across different teams, departments, applications, products. You're also going to reduce the costs, because most likely you're going to utilize a lot of different open source tools from the broad community, and it helps you to move forward. And of course, you get accelerated time to market, because with all of these benefits, you'll be focused only on your core business value. With all of that, I will hand the mic to my colleague Alex, who will tell you more how you can use Amazon EKS and generative AI together.
Thank you, Max. Okay then, so let's talk about how Amazon EKS can help you with running generative AI workloads. And the first thing that I want to point out here is actually an important difference between traditional machine learning models and foundational models. Now, with traditional ML models, you would first have to make a, let's say, upfront investment in collecting data that is relevant for your use case, then labeling that data, which is time consuming, and then training your machine learning model for this very specific use case. While with foundational models, you will take a large amount of unlabeled, so to say, raw data and use it to pre-train this foundational model, which is then going to be good at a bunch of tasks in general. And then you can use a comparatively smaller amount of labeled data to fine-tune this foundational model for your use case. And now the key difference is that in the future, if you come up with more use cases, you don't have to start from zero again. You can take your foundational model, train it with a, again, smaller amount of labeled data, and train it, fine-tune it for your new future use case. Now, what are the challenges with generative AI model training on Kubernetes? So the first challenge is scale. Now, what is the challenge here? You're not going to fit the training of your foundational model on just one node. You're probably going to need maybe tens, hundreds, or thousands of nodes, depending on the scale of your model. So you want to auto-provision infrastructure. And also, your control plane in the back needs to be able to handle this kind of node scale. Then the second challenge is going to be, like I said, one node is not going to cut it. We need more. So we also need to distribute all that data and the training onto these, onto all of our nodes. And the third challenge is then to reduce the impact of failures that are going to be inevitable when you are at this scale, hundreds of nodes, thousands of nodes. There's just going to be hardware failures, software failures, and you want to reduce the impact of these failures. Now, how can EKS help here with this large-scale distributed training? Basically, EKS's focus is to provide you with Kubernetes native access to AWS services from compute, storage, and networking. So on the compute side, we provide you with control plane autoscaling, which means if you have scaled up to, let's say, 100 or maybe 500 nodes, we may scale up in the background without you having to do anything to, let's say, 24 extra large nodes. And the key point here is that even if we scale this high, we are still going to charge you the same 10 cents per cluster per hour that we are going to charge you when you are at a smaller scale. And this is going to be much more economically efficient than to run the control plane yourself on EC2. Then we provide you with EKS accelerated AMIs, which provide you with built-in support for EC2 accelerated instances with, for example, NVIDIA GPUs or AWS's own accelerators like the Inferentia or Trainium instances. Then on the storage side, we give you access to Kubernetes native CSI drivers, which enable you to interact with AWS's storage services. And for example, the FSX for Lustre CSI driver is commonly used by customers who are running this large-scale distributed training on EKS. Then on the networking side, we also provide you with device plugins that enable you to use AWS network primitives inside of Kubernetes. One that I want to highlight here is the Elastic Fabric Adapter, or EFA, device plugin for Kubernetes. it enables you to use this AWS network device inside of Kubernetes, and therefore enables you to build clusters that need low latency, super low latency between the nodes, as well as high inter-node communication, giving you the possibility to build a cluster in the cloud with the same performance as an on-premise high-performance compute cluster, but with the flexibility and scalability of AWS. Now, let's move on from training to inference. What are the challenges here? The first challenge is scale again. However, this time the challenge is actually a little different. Now, with training, you are going to probably pre-provision a bunch of compute resources. However, with inference, it is more similar to a traditional web application workload, where you have to scale up or down based on the demand of your users. How much requests does your application get, for example? Now, the second challenge is performance. And yes, you also want performance in training. You don't want to wait forever for your model to be trained. But with inference, performance could stand in the pathway of your users, meaning if your inference performance is low, your users could suffer from or experience a long response time, which is a bad user experience, of course. And we don't want that, right? So the last challenge here is cost. And cost is always a factor, of course. However, with Gen AI models, it can be up to 90% of the cost for running your Gen AI workload. Why is that? You are probably going to train your model only at the start, in one big training probably. And then you're occasionally or incrementally going to train this maybe every other week or month, depending on your use case, with some fine-tuning or new data. But your model is going to run all the time in production. And this is why inference can make up to 90% of the cost here. Now, what can we do to solve these challenges? And one thing that we can do is use Carpenter. Now, if you do not know Carpenter, it is an open source project that we started a few years ago already. And it provides you with high-performance, flexible Kubernetes node autoscaling. Now, in a traditional autoscaling setup, you would predefine your compute resources, meaning you would have node group A with this instance type and node group B with another instance type. If you think about this, if you want to scale up, you may end up with hundreds of node groups, which some of our customers have. And this gets hard to manage. And also, you are not taking advantage, or it gets hard to take advantage of the flexible compute options that AWS offers. With Carpenter, this paradigm shifts from predefining your compute resources to just giving Carpenter a set of constraints that is as broad or specific as you need it to be. And then you just hand Carpenter your workload, telling Carpenter that you need, for example, 5 GPUs. And Carpenter is going to provide you with just-in-time, right-sized compute resources for your workload. Now, to be honest, we didn't design Carpenter with machine learning use cases in mind. However, we received signals from our customers that it works exceptionally well for these use cases, just as for other use cases. Now, are we satisfied here? No, we are not, because we like dissatisfied customers, because you keep us innovating. And of course, we are going to keep bringing you the latest and greatest innovations from AWS's infrastructure to your use cases. So what do we have in mind this year? On the compute side, we are working on giving you access to the NVMe CSI driver. And we are also working on giving you access, and I know, and we heard you, we know that you are waiting for this one. We are we are working on giving you access to the Amazon Linux 2023 based accelerated AMIs, so that you can base your machine learning use cases on EKS on the latest release of Amazon Linux. Then, on the Carpenter side, we are going to keep doubling down on the machine learning use cases. And I want to point out two features here that are coming in particular. The first one is savings plans. which is going to give you even more flexibility in cost optimization with Carpenter. And the second one is GPU time slicing, which is going to enable you to share your GPU resources among multiple tasks and splitting them up into multiple small time intervals. Then on the cluster performance and resiliency side, we are working on ever more improving the auto-scaling of the control plane, as well as giving you access to the node auto repair feature to decrease the impact of, for example, hardware failures. And one thing that I want to point out here is container image lazy loading, which is based on a technology called Seekable OCI that we open sourced in 2022. And the use case for this is that when we talk to our customers who are using machine learning on EKS, they measure their container image size in tens of gigabytes, maybe 50 or even 100 gigabytes in size. And what may happen here is that Carpenter may provide you with a node in 30 seconds and it's there, but maybe your image will then need 10 minutes to download, and this will slow down your training job, or your training job will start at a later time than you want it to start. Now with container image lazy loading, you get enabled to not having to wait for the complete download, but you can start your training job faster because this technology enables you to basically look into the image and take only what you need at this point in time. And yes, I know you can do this already. It is available today. However, it needs some setting up from your side, and we are going to work this year on making this easier for you. Which is also a great point for the last point here. Machine learning use cases on EKS should just work. You shouldn't have to do a bunch of configurations to make your workloads happen. And this is why we are going to keep giving you access to the latest drivers, for example, for NVIDIA GPUs or Neuron devices, as well as expanding the EKS add-on catalog and open sourcing the accelerated AMI build scripts to give you the opportunity to do customizations easier if you need to. Now, who's actually using this? Because it sounds great, but who's doing this in production? And I'm going to start at the lower level here. And these are companies who are building generative AI platforms as a service on top of EKS, which you can consume in a, let's say, Kubernetes-style experience. And then in the middle, we have customers who are running at the largest scale. These are the customers who are training their foundational models on top of Amazon EKS. And then at the top, we have customers who are building their machine learning platforms on top of EKS to build consumer-focused generative AI products. And now I want to highlight 3 customers from here in particular. And the first one is Anthropic. Now, you may know Anthropic for their Claude family of large language models. And so they are operating at a very large scale, right? And they needed to handle a bunch of challenges here, actually. Because in training these large language models, you need to do a bunch of tasks, like the actual training of the model and pre-processing large amounts of data. And for this to function, they needed access to seamless scalability, flexible resource optimization, and this all throughout the whole development and deployment cycle. Because throughout this process, you're going to need access to maybe a diverse set of compute instances, as well as a varying actual number of instances that you're going to use. And what Anthropic did was they leveraged Amazon EKS in combination with Carpenter and Amazon S3. Now, I've already talked extensively about Carpenter, and I may be a fan of Carpenter, but what Anthropic actually did was they heavily leveraged the flexible purchase options for compute instances that Carpenter gives you. And then they realized that they do not necessarily have to use persistent volumes for persistent storage inside of Kubernetes for model checkpointing. But instead, they realized that for them, S3 provides them with the right performance as well as a cost-efficient storage solution to do their model checkpointing. And for them, this resulted in a 40% in saved costs year over year, which is, for this use case, quite impressive, if you ask me. Now, the second customer that I want to highlight is Quora, which you may know as a place to share knowledge and better understand the world. Now, Quora actually faced a bunch of challenges as well, but rather common ones if you do machine learning at scale. So they struggled as well with resource optimization and underutilization, as well as just setting up training environments at scale. And their solution was to build their machine learning ops platform on top of EKS, which enabled them to integrate and standardize key services for them, such as Apache Kafka, Trino, Spark, and Airflow, for machine learning and data pipeline orchestration, which enabled them then to have a 25% reduction in cost for their platform, as well as, and this one I like a lot, they reduced the deployment time for new models from days to just hours, which is a vastly improved developer experience, if you ask me. Now, the last customer that I want to highlight is Adobe, and you may know them for products like Photoshop, Lightroom, or Adobe Firefly. And you may imagine that Adobe operates at a large scale, and they need a way to run their Kubernetes clusters in an efficient way, as well as orchestrate their machine learning operations. And for this, they chose to migrate from their custom-made Kubernetes solution on EC2 to Amazon EKS and build their machine learning platform on top of it, as well as their internal developer platform, which integrated their machine learning workloads. And doing this, for them, resulted in simplified operations. Now, what does this mean? To put it in numbers, they improved their cluster to operator ratio from a 10 to 1, so 10 clusters, 1 operator, to 30 to 1, meaning 30 clusters, 1 operator, which is of course impressive again, if you ask me. And also, using Amazon EKS as their machine learning platform ensures the long-term scalability for their use cases. Now, I have been a little light on technical details here, and you may ask yourself, how do customers run machine learning workloads on Amazon EKS? And this is what Max is now going to tell you all about.
Thank you, Alex. Yeah. So, Kubernetes is a great tool, there is no doubt, but it wasn't designed in mind with machine learning API and use cases. As a result, there are a lot of good things which easily applicable for application developers. They can use deployment, they can use services, they can use stateless sets, and all of that helps them to move faster and develop their applications. But it isn't straightforwardly applied to machine learning world, just because there might be some additional use cases, scenarios when machine learning engineers need to use infrastructure in different ways. And building from scratch or getting deep into the infrastructure and how Kubernetes works, all of these objects, components, and constructions, it might be tricky, especially for machine learning engineers. There are a lot of different stuff to learn for them and experiment with, and Kubernetes is, to be honest, shouldn't be one of them. And also, if you choose even how to solve particular problem, you need to also think how it can be aligned with the best practices, right? Because it might be tricky. If you're trying to solve something in the first place, in the first time, it should be done in this way, in that way. That's how we hear our customers building different applications in-house, on their side. And when they decide to adopt Kubernetes, it usually goes for what is good for. And it is good for orchestration, basically for orchestration and infrastructure management. A lot of different components, very useful, and helps customers to set up their bases. And next, customers building their own ML platforms on top of the Kubernetes. A lot of our customers building this on top of the Amazon EKS. It gives you some basically structure. It gives some ways to make decisions faster because they're already built-in capabilities which can support their machine learning journey. And then when we come into the topic related to the machine learning operations, there is open source. A lot of different tools which you can choose, adapt, configure, and run for yourself. But we hear from our customers that it's not always easy and possible to quickly choose a proper tool, because there are a lot of them, they are different, they require experience. And that's how we've come up with the idea of JARC stack. It basically stands for Jupyter Hub, Argo Workflows, Ray, which are running on top of Kubernetes. So it's our opinionated stack, which we think that can help our customers move faster. When you deploy everything in your Kubernetes cluster, from first impression, to be honest, might be a little bit complicated, right? A lot of different components. But in reality, it isn't. So everything runs on top of the Amazon EKS. Your data scientists get access to familiar environment, which is basically Jupyter Hub. They grab their models from Hugging Face. They can do their own machine learning models or algorithms. They can do automations with Argo workflows if they need for end-to-end parts related to machine learning. And then, when they want to deploy their model and start inference, they start using basically Ray, which helps them to parallelize the models and expose the interface for their own customers. And in order to deploy such an architecture, we've created a simple template. It's Terraform template, which you can just find on GitHub and deploy in your environment with a simple apply Terraform command. The result, you will save time, you provision this infrastructure, and your teams may start working from today already on their machine learning applications. But this is not all, because as we all already know, that you can't build successful machine learning applications, especially in generative field, without proper data strategy. We hear our customers. A lot of our customers want to use some open source tools which they have experience. It might be Apache Flink, it might be Spark, so a lot of different tools. And we hear our customers and we try to support them. That's how we've come up with the idea of the project called Data on EKS. And basically a set of templates, let's say blueprints, which you can deploy in your own environment. They all set up according to the best practices. You can easily reach out to us on GitHub, you can ask your questions, you can try to run it in your own environment with sample of codes. And it can be done in a simple way, in the same way with Terraform templates. And by the way, the actual Terraform template for JARC stack is also part of EKS blueprints. So you can choose whatever you need at this point of time in order to start your progress towards proper application on Amazon EKS. And now we are coming to the takeaways. Let's just briefly summarize. So with all the things which we mentioned today, you can get your accelerated time to market. Basically, you're going to reuse what you already have or were built on top of the Amazon EKS and still remain compliant and secure towards your goals. You're also going to optimize your costs because you're going to use open source solutions. There are a lot of different projects, as we already told you today, and you can adapt them towards your needs and meet your goals. Also, you can scale your infrastructure towards your customer needs. With Amazon EKS Managed Control Plane and Carpenter, you can scale your distributed training, you can scale your inference to the would say, to the horizon. And with a project like Data on EKS, you can easily spin up all of these infrastructure components, save your time, and start working on particular projects. And today we also mentioned a lot of different sources, right? A lot of different projects. They may be a little bit complicated, especially if you haven't worked with them before. That's why I want to mention today skillbuilder.aws. It's our resource. There are more than 600 of different courses, which you can just grab on your own, do some practice labs also there, some role-based games, and get some experience with all of these tools. And then become more confident and move forward towards proper generative AI applications. With all of that, thank you very much for your time. It was a pleasure to see you here. Please don't forget to fill out your survey, and see you next time.
Thank you.